so this was question 3 from the problem solving section of your homework. Now, the question basically is talking about the number of bacteria in the colony represented by N, and we're talking about time being T. So essentially, it's exponentially distributed. Wonderful. Now, we're saying that ultimately the equation is represented by this, meaning that to start with, there was 1,000 bits of bacteria. We know that because obviously time would be 0, and this would be e to the power 0, which would be 1. So when t was 0, at the start, there was 1,000 bits of bacteria. Okay? We now want to work out what it is for 2 hours. So how much bacteria is there after 2 hours? So we simply understand that time is 2 and substitute that into our equation. So the number of bacteria is 1,000 times e to the power of 0.4, because it's t times 0.2. And that just substitutes straight into our calculator, and we would get 1491.824, something. I then understood, obviously, I can't have decimal points in terms of numbers of bacteria, so I have to round that to the nearest bacteria. Okay? The next question wanted to know how long it would have taken for the bacteria to have doubled. So we're essentially looking for t, given that we know the number of bacteria. So as we talked about before, we need to make sure that that is 2,000. That is double the amount of bacteria that there was at time t equals 0. So we've got 2,000 is equal to 1,000 e to the 0.2t. Okay. Now we're just looking at trying to solve this. So I can simply divide my numbers. So I've got 2,000 divided by 1,000 is equal to e to the minus e to the 0.2t. This is obviously going to simplify to 2. Now I need to get the t away from the fact that it's in a power of e, so I'm going to ln both sides, which cancels off the e from here, and then we're simply going to divide by 0.2 or multiply by 5 to get t on its own. This would give us a total of 3.465 hours, which if we wanted to convert into minutes, we would have had 3 hours and 28 minutes to the nearest minute.